Hello everyone, I am Dr. UK Poddar and welcome to my channel Poddar Tutoring Club. In this channel, I will be sharing maths tutorials, maths concepts and problem solving strategies to help you understand and excel in maths.
Recurring decimals can be classified into two ways. First one is pure recurring decimals, second is mixed recurring decimals. So recurring decimals are of two types, pure recurring decimal and mixed recurring decimals. We will discuss each one in details. Pure recurring decimals, that are also known as purely periodic decimals. Pure recurring decimals are decimals in which all the figures or digits after the decimal point are repeated. Means if you consider the decimal and after decimal point, if all the digits or all the figures are being repeated, then we say that the decimal is of the series, is of the type pure recurring decimals. I mean to say, pure recurring decimal are decimals that have a recurring pattern immediately after the decimal point with no non-recurring digits. Once again, I am telling you, pure recurring decimals are decimals that have a recurring patterns immediately after the decimal point and with no non-recurring digits. After decimal point, there's no any non-recurring digits. Whatever digits available after decimal point, those digits are repeating only. That is pure recurring decimal. For example, 0.333 dot dot dot. In this decimal, 3 repeats continuously. 0.666 dash 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 dot dot dot. Here 6 repeats continuously. Since 0.3333 is there, so this can also be written as 0.3 bar. 0.3 bar indicates that this decimal is pure recurring decimal because only 3 is there after decimal point and this 3 is repeating continuously. 0.666 dot dot dot, which can also be written as 0.6 bar. It indicates that the digit 6 is there after decimal point, which is repeating. 0.142857 142857 dot dot dot. Here 142857, these all digits are repeating in pattern. If you consider one pattern 142857, then you will see that this pattern is coming continuously. So this will be written as 0.142857 bar. So this is pure recurring decimal. So I think it is clear. That pure recurring decimal, after decimal point, whatever digits are there, these digits or each and every digit is repeating or pattern is repeating. Next one is mixed recurring decimal. Mixed recurring decimals are decimals in which at least one figure or one digit is not repeating. कम से कम एक डिजिट ऐसा जरूर है डेसिमल पॉइंट के ठीक बाद जो कि रिपीट नहीं कर रहा है, बाकी डिजिट्स रिपीट कर रहा है, लेकिन एक कम से कम, एक से ज़्यादा भी हो सकता है, एक से कम एक अगर रिपीट नहीं कर रहा है डेसिमल पॉइंट के बाद, तो हम लोग कहेंगे कि ये डेसिमल मिक्स्ड रेकरिंग डेसिमल्स के सीरीज में आता है। इसको दूसरे तरीके से अगर समझेंगे तो मिक्स्ड रेकरिंग डेसिमल्स आर डेसिमल्स दैट हैव ए कॉम्बिनेशन ऑफ नॉन रेकरिंग and recurring digits after the decimal point. I think it is clear. Non-recurring and recurring after the decimal point. If you take one example 0.583333 ... You see, after decimal point 5 and 8, these are the digits which are not repeating but 3 is repeating. So this can also this will be written as 0.583 bar. So bar is given only on the top of 3 because 3 is repeating. 5, 8 is not 5, 8. This two digits are not repeating. Second example 2.416666 ... So here, after decimal point 4, 1 are non-recurring, not repeating, but 6 is repeating. That's why it will be 2.416 bar 1.39. 0.45 can be converted easily as 45 by 100, that is equal to 9 by 25. So in this way we can convert this decimal to vulgar fraction. Similarly, we can convert the following vulgar fractions into decimals also. Dividing by 3 from 5 will get 0.6. So in this way we can convert decimals into vulgar fraction. Express the following recurring decimals into vulgar fractions. Here are some recurring decimals given. We have to change these recurring decimals to vulgar fractions. First of all, we see how to change these recurring decimals to vulgar fraction. Let us take one example, that is A 0.6 bar. Let x is equal to 0.6 bar. Multiplying, which can also be expressed as x is equal to 0.666 ... Because this is recurring and here 6, this digit is repeating, that's why we can write 666 ... Suppose this is first. Multiplying first by 10, we get what we are getting, 10x. If you multiply by 10 here, 10x
is equal to, if you multiply 0.666 this is going to infinity, so it will become 6.666 and this is second. Now subtracting first from second, second minus first implies 10x minus x, that is 9x, is equal to 6.666 minus 0.666 that will be equal to 6.0. okay, and after that x is equal to 6 by 9, which can also be expressed as 2 by 3. So this 2 by 3 is a vulgar fraction. So we can change this vulgar recurring decimals. We can change this recurring decimal to vulgar fraction. I think you can solve 0.16 bar, 0.234 bar also. Thank you. Express the following decimals as vulgar fractions. Here are some examples given, and these are decimals or decimal numbers. We have to change these decimals to vulgar fraction. Let us take one example. A, that is 0.17 bar. Here bar is given on just 7. This 1 is not repeating where 7 is repeating. So this decimal is the recurring decimal, that is correct, but this is mixed recurring decimal. So how to change this mixed recurring decimal to vulgar fraction? Multiplying, suppose this is first into 10 implies 10x is equal to 1.7-777 ... This is second. Again multiply second by 10, you get 100x is equal to 77.777 ... This is third. Third minus second implies 100x minus 10x, that is 90x. 17.777 minus 1.777, that is 16. So x is equal to 16 by 90. X is equal to 16 by 90 we have, and this can be changed to the simpler form, that is 8 by 45. So this 8 by 45 is the vulgar fraction, and we have already changed this 0.17 bar to this vulgar fraction 8 by 45. In this way, decimals can be changed to vulgar fractions. Either decimals are in pure recurring decimals or mixed recurring decimals. Thank you. Here some recurring decimals are given, and these recurring decimals are pure recurring decimals and mixed recurring decimals. For example, 0.56 bar. So this bar is given in each digit after decimal point. That's why this is pure recurring decimal. 6.56 bar, here also just after decimal point digits are repeating. That's why this bar is given. So 565656 dot 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 like this it will be coming. So this is also pure recurring decimals. 6.256 bar, here bar is given on 5 and 6 only. It means 5 and 6 are repeating but 2 is not repeating. So here there is the combination of repeating and non-repeating digits. That's why this one is mixed recurring decimals. 0.17 bar is mixed recurring decimal. 0.1254 bar 54 bar mixed recurring decimals. So pure recurring decimals and mixed recurring decimals both can be converted to vulgar fractions or fractions. Now here we will change these decimals to fractions in very shortcut method. In 1 second we can change. There's no use to give the details and to find fractions over these recurring decimals. You see how. 0.56 bar, just observe the number. Before decimal point there is 0, so you see only 5 and 6. How many digits are repeating? 2 digits are repeating, so there will be 29. And what is given after decimal point? 56 minus, is any digit which is not repeating? No any digit, so minus 0. So this is equal to 56 by 99. So this 56 by 99 is vulgar fraction. Come to the next example. Before decimal point here we have 6, write here 6. After decimal point 56 is given, 56 minus 0 by 99, which can be solved easily. 6.256, 6 you write here, and after decimal point 256 is there, so write 256 minus how many digits which are not repeating? 2 only, so minus 2. How many digits are repeating? 2 digits, so 29 will be there. How many digits not repeating? Only 1, so 10 will be here. We can solve this one and we'll find the values. Like this you can solve this and this also. Thank you.